This going. Now we're recording. And we do sharing of the whole desktop so that I don't have to go nuts flipping shares. All right, so let's do a new tab. And okay. There's that. Now let's get an editor going. What the hell is this? That's not what I asked for. Let's do it again. Getting that. Now, are the characters here big enough for you to read? Okay,
I can read them.
good.
Yeah, we can read.
All right, and okay, so let's open the folder. And go to again. Let's get in our SFTP. Okay, so now let's create a new file. Okay, so let's just make sure it transfers over to the virtual machine. Good. Okay, let us begin. So I'm going to talk you through my process. And, you should not be writing spaghetti code. You know more, you know that, and you shouldn't be doing it in assembly language. Assembly language is no different than C++. Okay, so global main dot align to, and that's in dot text. All right, so let's first make some messages. What are the things that I'm going to cover? Let's see. So bad F is going to be dot ASCII V. Could not allocate fixed buffer. That's double quotes, isn't it? I'm doing Python. Let's see, bad T could not allocate tail buffer. So I'll be doing that. Bad O ASCII Z could not open file. And how about also usage ASCII Z must supply a file name. All right, that'll get me going. All right, so main. We're going to use a bunch of registers. So you got to back up your registers in main. Anything in the 20s up through 30, you have to back up. I'm going to use quite a few. So I'll just start backing them up. So let's say X20, X21. You know this part. Let me copy this. All right. So 21, 22, and 23, 25, 27, and I don't think I'll get to 30. So let's see, 22, 23, 24, 25, 26, 27, 28. All right, that's all the registers I could possibly want. Happy, 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 joy, joy. Now let's reverse these. There, 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 there. So now I'm in the inverse order, correct? 30, 27, 25, 23, 21, 21, 23, 25, 27, 30. Okay. And change these to LDs. And okay. Look good, everybody? All right. Now, my habit is the very last label. I always do 99. Okay. Now, here's something you need to, I was hoping that you would find on your own, but many people did not. So I'll just show it to you. You saw .equ, so fixed size, that's 4096. You've mastered that. .equ, um, um, tail length is 10. Now, here's the part
You
that,
forgot the comma between tailend and 10.
thank you. Okay, so here's something new for you, which I was hoping that you would find, but it's okay. So let's see. Fixed buff, fixed, what should I call it? FX buff P dot, that is going to be X20. Here is the tail buff pointer. That is going to be X21. I need a safe register that I can use as scratch up in the high numbers so that I don't have to reload it, store it. That is going to be X22. Let's begin. That'll get us started. So if you were writing in assembly line, if you were writing in a high level language, you'd be using functions and functions and functions and functions. You would not be writing spaghetti code. So first order of business is to check the arguments, right? So I'm gonna BL to check args. Let's write that. Check args. And it turns out this one is going to return true. No, that's not true. It's going to return argv sub 1 in x0 or null.
What exactly does .rec do?
You're about to see it. Not quite yet. I'll point it out. I'm just going to keep going, okay? So check args. And I know that I'm calling this as the first thing. X0 and X1 are still fine. So I'll say int argc char star star argv. And it's going to return argv sub 1 in x0 or a null if the argv sub 1 is not defined. And this one's going to be a real easy one. It's going to be 2 statements long. You ready? Here it goes. Move, no, that's not true. LDR into x0 of x1, advancing it by 8 first. Return. Okay? So if argv sub 1 is not present, that will put a null. So compare and branch not 0 of x0 to 1 forward. And what does that leave us here? This is the error case. So we'll handle the error. ADR x0 of usage, BL to puts, branch to 99. Okay. So this says if x0 is 0, it's because argv sub 1 doesn't exist. So if x0 is 0, it's going to print the usage and exit. So great, let's try that. All right, let's take a look here. And okay, so gcc-g main.s. All right, and branch to 99f. All right, so I'll get right down to it. I'll start testing immediately, all of it in Valgrind. So here's the case where it's not going to, it's going to print an error. I'll do all my testing in Valgrind. This way I will know that if there's any issues going on, I'll know about it immediately. You write a little, you test a little. So there's my error message, must supply a file name. All of my heap has been returned, no chance for a leak. And also there's no errors. All right, so what's the next thing I'm going to do? I'll open the file, okay? So BL to open file. Okay, here it comes. What's it going to do? Open file, and this is going to be char star file name. Returns -1 if failure. Okay. Returns 0 or more if succeeded. You can stop me. You should stop me as you have questions, right? Because I don't love doing this. And I want you to get the most out of it. Okay? And I expect everyone to ask a question in this class. I just do it.
I have
Okay,
a question.
go ahead.
At the above, the main portion, when you
Yeah.
assign x20 through x22 to buffers, can you explain what that means? Because I've never seen that notation. I don't really understand what's going on there.
Okay, finally, I will answer the question. Let's add another one. So FD, that's my file descriptor.
Okay.
Dot F23.
So as it requires that register?
Actually, I have no idea why it's .req, but you'll see what it's going to do in a moment. All right.
Okay.
So, so X0 already has the file name in it. as passed in as the argument. So move, we're talking about W1 from WZR, that's the read only. BL to open, and then compare X0 is where the result comes back. Compare, no, does not go in X0, it goes in W0. By the way, many of you who had errors in Valgrind, it's probably something to do with using a W where you should have had an X, or using an X where you should have had a W. Okay, that's the cause of most of your errors in Valgrind. So compare W0, WVR, and what we're looking for is branch greater than or equal to 1 forward. Now this function called a function, therefore I must do this. I don't know why my cursor jumped down there. Therefore I must do this. And I must do this. Okay, as soon as I see that I've called a function, I have a BL inside this function, I must back up X30. No ifs, ands, or buts. So let's put in this here. Now, branch greater than or equal to. So 0 or more, it's going to go to 1. This is the error then. So ADR into X0 of could not open file, that's bad O. Where am I typing? Okay, bad O. And BL to PR, move. And this is going to be into W0 minus 1, branch to 99 forward. Here's 99. As I said, I usually use that for the last thing before exit. Okay. So if we get here, file is open. All right. So here comes .req. Move. And notice FD is X23. That's wrong. Make it W23. You got to make sure your W's and your X's are assigned correctly. So move. There. Okay. And since W0 already has the return code of 0 or more, I'm all set. There, the whole function's done. That did the open of the file. Any questions?
This would have been very convenient to know a long time ago.
Okay.
Well, with P error, is that a function like open? Like one that we don't create, or is that something that comes in the library? And is there what's the things that P error needs? Because I don't remember seeing it or remember it.
Okay, so I think I have used it. And with regard to this being very, very useful to have known before, we went through the file that has all of the assembler directives in it. I didn't explain everyone, but I gave you the file.
This one is not. I looked it up. It's not
Really?
in there. Mm-mm.
Okay.
The MIT one? Like
no, using AS.
Yeah, from MIT.
Well,
it's on the
posted
MIT
at
website.
Yeah.
Yeah, that one's not there.
All right, maybe there's something similar, but okay, so this is sort of making a pound define that works with registers. So whenever I say FX buff pointer, it's really going to be X20. And this way I can remember very easily what a register is being used for because it's in letters instead of X0, X whatever. Okay. So I wrote a little, let's test a little. And Rebecca, I know that you're asking questions about Pierre. So I'll show you what Pierre does. Valgrind a.out with a bad file name. Okay. So could not open file is the string that I gave it. And Pierre filled in the colon and a real error message. No such file or directory. Okay, so that's coming from the standard runtime environment. Once again, all heap blocks were freed and no chance of a leak and no errors. All right, now I might as well write the close file because I'm going to need one of those. Close file. I know I'm calling a subroutine. I'm calling close. So I better back up X30 and restore. And I'll do that here. And write the comment. Close file. And the FD is, well, do I need to put it in X0 now? No, I don't. I don't need to put it in X0 because I have a register designed just for it. But if I have a register reserved for it, I better make sure that it's initialized to a bad value. So let's go to main and move to FD, and that is going to be -1. Right, so that's the initial value of FD. The initial value means it's not open. If FD is 0 or more, it is the file descriptor of an open file. Close it. Okay, so compare FD to -1 and branch if equal to 99 forward. Right? Move to W0 FD BL close. There, done. Okay, you should be right. You know how to write assembly language because you know how to write C and C++. So all I'm doing here, folks, is breaking down exactly how I would have if I were writing in a high-level language. All right, let's do that. Let's add that. On the way out, I'm gonna just put that up into 80s. So BL to close file. Now let's test that, make sure that works. So every instant that I add code, I then will write code to, I'll then test it. So what's the hell? Okay, main.s. Yeah, I expect no output. Okay, no output and no errors and no heap allocation problems. All right, the file's open now. Let's write a function to allocate memory. Right? But that's not quite right. We need to do a check of the return value. So close open says that it will return -1 if failure. So right here, compare FD to -1, because that is where, that's not correct. Let's do W0 to -1. That's where the return value is. And this one, think about it. So let's see, compare and then branch greater than or equal to 0 to 2F. So if we get here, the file failed to open. And we've already printed the error message. And that means we can just go to 99. All right, so I'll say branch equal to 99. And that means I don't need a 2 there. All right. Now there's kind of a dividing line between where if I do a certain amount of work, I don't have to clean up. But if I go beyond that dividing line, then I do have to clean up. So notice this branch to 99, branch to 99. There's no cleanup at 99. It's because I haven't allocated anything. So there's nothing to clean up. But once I have an open file, then to exit the program, I have to pass through line 80. So once the first thing has been allocated that I have to clean up, then I have to pass through all, I'm going to write all of these cleanup functions to work whether or not the function has any work to do. So for example, close file will test to make sure that the file really is open or closed. So I can call close file, whether or not a file is actually open. Okay, so I've opened the file. Now let's call alloc buffers. And you'll see quite a bit here. So alloc buffers. And this is going to return return 0 in x0 if there's if failure. Return non-zero, doesn't matter what the value is, if success. This function will do 3 things. 1, allocate fixed buffer. 2, allocate the tail buffer. 3, initialize T and P. T and P. So that's going to be a pointer, T and P dot REQ X, it's a pointer, 24. And T and P to the address after the end of tail buffer. Okay, think about it. We have to make a circular buffer, right? And to do a circular buffer, we need to know when we've reached the end of the buffer so we can circle back. Now, you probably, in your implementation, did it with a counter, right? An index. But if you do it with an index, that means you have to do the multiplication by 8 back and forth, right? Because when you want to get the next pointer, you have to multiply the index by 8 and add it to the base address of the array to get the next value. If instead you do it the way I'm doing it, then your index, so to speak, is always kept as an address. And you just have to add 8 to it. To increment it to the next address. So there's the end of the buffer. And then the next is going to be x25. So that is my circular buffer index, next P. All right, so let's do. Move into x0 of fixed size. BL to malloc. Compare and branch, if not 0, to 1 forward. So here's the failure. So ADR to x0 of bad F. BL to puts. Move of anything other than, so 0 is a failure. So move into x0 of xzr, branch to 99F. Okay, let's write 99F. 99. This is going to be LDR X30 SP16 return, and up here STR X30 SP -16 exclamation point.
You forgot the negative sign.
Thank you. Thank you. That's how bugs happen. All right. So does anybody have any questions about this so far? All right. Then let's add, here's 1. Move into x0, and that will be tail end, right? Move into x1, 8. There are 8 bytes each. Mul x0 by x1, put it back into x0, and call, but I'm going to do something first. Now I have 80 in x0. I'm going to store the 80 in my safe register, because I need it to set up end P. So branch to link of malloc, compare and branch not 0 to 2F, and that's going to be, I always make this mistake, and I made it up here as well, didn't I? I always leave out the register. Okay, so if I get here, we failed to allocate tail buffer. Okay, so ADR of bad T, BL to puts, put a 0, make sure my return code says failure, and branch to 99 forward. Okay? Anybody have any questions?
So why did you store the 80 in the safe again?
Okay, here it comes. So we have buffers are now allocated. Initialize T end P with the address off the end of T buff P. Is that what I spelled it as? Yes. And we're going to do something smart. Look at the same file twice. And that way I can keep this here while I work on my code on the left. Okay. Buffers are now allocated. So move T buff P from X0. So now that is the result of the malloc, right? So I need to remember that.
Don't you need to make a to label here?
Yes, I do. Good, good. All right. So my buffer pointer is now stored correctly. And now I want to create T end P.
Where did you call
So,
malloc? I don't see it written out.
right here.
Oh, I was looking in the wrong spot, of course.
Yep. Okay, so now, what I want to do is the T buff P, okay, yeah, add, who the hell told you to type that? So T buff P is already in X0, so I'm going to add the safe. That's got 80 in it. Now X0 has 80 plus T buff P, and that's going to go in T end P. Now X0 is already non-zero, so I just have to return. Okay? Okay. Anybody have any questions? So I wrote a little, let's save a, run a little. Okay, so if I build it now and I run it, I will actually leave over 4096 plus 80. So we can expect that. Because I haven't freed that memory. Okay. So 4096 plus 80 is, I assume, 4176, correct? Okay, so no crashes yet. Next, I'm going to handle the zeroing out of the fixed buffer, which I have to do a lot. So I'm going to make a function out of it. Clear fixed. That's going to call memset. So I need this. Since it's going to call a function, I know I have to have x30. And let's take these three, 2. And that's good. Now this is a void function. Okay. So that's going to be move into X0, no, X2, the 4096, right? Move into W1 of WZR, that's the fill value. That's got to be a W. And then a move of into X0 is going to be FX buff B. Where did I save FX buff P? Look at that. I didn't save it. Let's see, go to 1. Yep. Okay, there needs to be a statement here. So X0 currently has the address of the fixed buffer in it. So move of fx buff p of x0. Okay, good. There we are. Now, just to make sure that we are initializing everything before we use them, move of fx buff p of xzr and a move of t buff p xzr. I don't need to initialize t end p or next p. Yeah, let's initialize next p. Where's that going to be? That's going to be right here. So that starts out as 0, right? That is the it's not 0, it's the index, the t buff p sub 0 is next p. Does everybody get that? Right? Because it's pointing to the same place as the start of the array. Okay, so what was I writing? Clear the fixed buffer. All right. And now let's use that, and then we better test again. So here we go. DL to clear fixed. Okay. Anybody have any questions? Okay, once again, let's come down and look at main. Main is going to be mostly function calls. So very straightforward. Main is going to be short and simple and sweet. Okay, so after the allocation of the buffers, which I promise will be 0 if failure. So branch, compare and branch 0. 0. Come on, God damn it. Goddamn features. Features suck. So compare and branch 0 to ADF of x0. Close the file and free memory, free buffers that I call it. I call it alloc buffers. I haven't written that yet, so let me put in a stub. Free buffer. I'm going to call function, so I got to have the STPs. And now give me an str. Okay, so I've stubbed out the function. So open the file, alloc the buffers, close the file, free the buffers. It'll maintain the plural. All right, so let's, we still haven't written the freeing of the buffers, so we're still going to have a Valgrind finding 4,176, but I'm also looking for errors. Okay, no errors. So what am I going to need next? I go back to look at main. I'm going to need to free the buffers. Let's take care of that. That's actually going to be a bit of a more complicated than just freeing the tail buffer, because you have to examine all the members of the tail buffer to see if they are non-zero. And then freeing those, and then you have to free the whole tail buffer. So free buffers, no arguments, will, if needed, free the fixed buffer and also each of the members of the tail buffer, then finally the tail buffer itself. Now I know what order I'm doing it in, right? When I allocated the memory, I allocated the fixed buffer first. So in free buffers, if the fixed buffer is null, then I know for sure the tail buffer is also null. So I'll just check. I'll check now. So compare and branch if 0 to of which register? FX buff P, and go to 99 if it's null. So if the fixed buffer is null, then that's all I have to check, because I know that the tail buffer must also be null. So let's free the fixed buffer. And that would be a move of into X0 of FX buff P and BL to free. Boom, done. Okay. So now check the tail buffer. So compare and branch of 0. I suppose it's possible, it's somehow possible, maybe, that the fixed buffer could have been allocated and then the tail buffer failed. It could happen. So X T buff P to 99. And free the, okay, now we have to examine the members of the tail buffer to see if they need freeing, then free the tail buffer itself. Okay, so this one's going to be a loop. And I need a safe register to act as my loop counter, but I'm not using an integer as the loop counter. I'm using addresses. So move of into safe of T buff P, okay, which I know is non-null. And 1, compare safe to the end. This is what makes it so much easier.
So do we not
And
care about the that was stored previously in safe?
no, we don't need, it's a scratch register.
Okay.
Whenever I use it, yeah, whenever I use it, I'm only going to need it for what's in it for a few instructions. But
Okay.
because I know that while I need to remember it in this loop, I'm going to be calling another function, namely free. I know it has to be in one of the safe registers in the 20s.
Okay.
Or I could have used the stack, but I did it this way because I have the registers available and I want to go as fast as possible.
Okay, thank you.
So is it bad to allocate, like, so when you're allocating or you're deallocating, I should say,
I'm
you're
deallocating.
checking to see if there is something that it's pointing to. Would it do anything bad if it wasn't, like, if it potentially had nothing?
You mean to free something that's not allocated?
Yeah.
Yeah,
So
that's
like you're
bad.
checking to see if this is if it's 0, you don't you skip over it basically.
Correct. Right. Freeing something that's not been allocated is an error,
Okay.
even if what you're trying to free is at location 0. Right? Try to free a null pointer, it's bad. Okay, so branch if equal to
So you're
99.
saying I can check for if this is null, but I can't do anything with the null
If it's
besides
null,
check it.
if it's null, skip it. Right? Here, watch. So I've got, so safe is doing double duty. I'm using it like my loop counter, and it is going to give me the address of the pointer to be considered it to be freed. Here, watch. So LDR into X0 of what's at safe, and then increment it to the next pointer. Compare and branch if 0, X0 to 2. All right, so if it's 0, I branch to label 2. If I'm here, free a string in the tail buffer. Okay, so that address is now in X0. So BL to free and a branch to 1 backwards. And here's 2. Free the tail buffer itself. And that would be a move X0 of T buff P, BL to free. Done. And try this and see what mistakes I've made, because it's possible to make mistakes. All heap box for everything is free, no leaks possible. But ooh, look, I got an error. Conditional jump or move depends upon an uninitialized value. Let's take a look around main 131. Okay. So what's
I
happening
had this
around?
bug.
What?
I had this bug. It's
Okay.
annoying.
I know what the problem is. You know what the problem is? It's exactly what the error message says. Uninitialized value. What's the uninitialized? The tail buffer. So let's go back to alloc buffers. Find out where we have established. Okay, so here we've got it. I've done what I need to do. And now I want to call memset on tbuff p. Okay, so move to X0 from tbuff the pointer. Move to W1, WZR, and now, let's see, so what's in safe? Good, safe still has 80 in it. So I just need to, and the safe register is an X register. Move to X2 from safe, BL to memset. And build it. And now I'm expecting that error to go away. Look at that, error is gone. Okay, so in the future, when I run your code under Valgrind, I will deduct points if you have any errors, not just the leaks. And what was that error caused by? Well, first of all, here's the text of the error. And the source of the error at around line 131 was here. I was loading from the tail buffer, but the tail buffer had not been initialized. That was the source of the error. Okay. So at this point, what have I done? I've opened the file, reported errors if the file couldn't be opened. I have allocated the memory that I need for the tail buffer and the fixed buffer. I have written the code to close the buffer, close the file, free the buffers. And I've tested it to the point where I know there are no errors, no leaks. Now, where do I have branches? Naked branches. I have, B99, that's inside main. That's essentially a brace in your higher level language. Any other naked branches? Well, here's one. That is, it's staying within free buffers. That's a brace, that's a loop. What about other naked branches? Okay, that's only within this function. So this is not spaghetti code. All right, and I'm at 185 lines, and I did it in less than an hour. So let me reveal in Finder. And I'm going to copy, put this file online. So it's in temp, okay. Where is my browser? I'd really, really like to see my browser. All right, so new window. Mediafire. Go to 3510. Upload, select. Temp. And again. And look at that, it didn't select it. Let's try it again. Now it did. Second time that happened. Okay, copy a link. And it's going into the chat. Everybody download this. So, yeah, we could back up X29. X29 is used by GDB, but in particular when it's working with higher level languages. So download this file, everybody, and then every single one of you has to ask a meaningful question about it. Okay, and we will do it in the order in which you are on my screen. So that would be Thomas first.
Well, let me open the file real quick.
All right, we'll wait.
I'm still confused where it is. Sorry.
Confused
the
where
chat.
what is?
The file. Oh, it's in the chat.
Yes, it's in the chat.
Is there a reason that you choose MediaFire instead of just using Google Drive or whatever?
Yeah, why use something for free when you can pay for it?
But doesn't,
Or just use
I'm pretty
Discord.
sure Carthage gives everybody here access to it. If I'm not mistaken. Like
Well,
I have,
the reason is very simple. I needed a place to put files that everyone can get access to, and I didn't remember Google Drive. So I paid $100 and I got MediaFire.
I have a quick question about R equals.
Yeah, R equals.
Like the dot R equals when you make like safe and buffer.
Oh, yeah, okay, yeah.
So if we were to use like X20, X21 later, not using like the name, it's the same as affecting like if you call it safe.
Yeah, so if you used X22, it's X22, whether you called it by SAFE or X22.
So if I were to like do move 0 into X22, when I call safe, safe will now equal 0.
Correct.
Okay.
Right, so these are all aliases. But at least when I use the alias, I'm getting information about what's in the register.
So the XFBuffP returns a pointer to a register, or just is using the register itself?
It's using the register itself.
Yeah, because I was just like thinking of some of the other times where we had global variables. It gives you a pointer to a pointer, so you have to dereference the pointer to be able to use it.
Correct, but these are not, this is not like that. These are just synonyms for the registers themselves.
Right.
These are not global variables.
And I'm guessing that's not an important enough question. All right.
No, I think I answered your question. It's a very good question. Is your question answered?
Yes, that does answer my question, and that will probably help for a lot more assignments, so I don't accidentally put X22 instead of X21 for
Exactly.
trying to do something.
Right.
I have a question.
I'm so pleased.
So it's kind of related to the project, not necessarily to what you wrote. So when you call read, or functions like that where it writes to a temp buffer, in C code, it happens quite a lot with syscalls.
Mm-hmm.
So what's the best way to do that in assembly? Because initially I did like a malloc of just a small amount of data, but then I tried to use the stack where I like move the stack by just a little bit and then write to that location and then move the stack back up. Is there a preferred way, or am I just thinking that
No,
wrong?
both of those are equivalent. The only thing to remember is that the stack must be moved in multiples of 16. Right.
Is stack manipulation cheaper than mallocing?
Oh, yeah, definitely. Now, what Cephas is talking about, I believe, you tell me if I'm wrong, is let's say you exceed in the project, this project, if you exceed the line fixed buffer of 4096, you have to still continue reading, but throwing away what you read. Is that what you're talking about, Cephas?
Yeah.
Good. So what I did when I wrote this program is I just had some scratch space here. That's too long, so TMP, and I just did space 8. Okay, so when I needed to give an address to read, I gave it the address of TMP. And what Cephas is also talking about, the way that he did it, is he made a little extra space on the stack, gave it read that address, and then picks up the stack afterwards, and it's exactly the same. So his method, my method, pick one. They work equivalently. Okay. Okay, so Thomas, you did ask a question. Can I ask you to ask one more?
Sure. This one's more about how you want us to document things. For documentation, do you want a summary of what a function is supposed to do? Would that suffice, or do you want just like a specific format for it?
Okay, there is, a recommended format. But having said that, when you go out into your career and you join a team, one of the first things you'll do is ask them what their standard is, and whatever the team standard is, that's what you'll adopt. The format that I generally used is this: function name and signature, and then this function, and describe the overall purpose and method of the function's operation. Then I will say parameters, and for each parameter, I will give, let's say, so I'll say foo is an int, and this parameter holds foo. But of course, I would never say that. I'll give you 0 if you say that. All
It
right?
holds this for this purpose is what you would probably
Yes,
want. Yeah.
it holds the file descriptor. For example, bar, char, this parameter contains a joke. All right, and then returns. Now make an int. Returns an integer. If 0, it means good things happened. If 19, it means blah 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 blah, etc. Okay, so this is the format I use for function comments. So I kind of did that in the code that I wrote today, but no, this is what I would do here. Now, for comments in the code, you don't remember, folks, you don't comment what you're doing. You comment what you're thinking about. So, for example, the fixed buffer is finished. Okay, well, now I understand that everything that I had to do with the fixed buffer is now done. So don't ever do something like this. In your high level code, maybe you have a statement like that, and you might be tempted to say, don't do that. Okay, just don't. Anyone who can read the code and understand it knows that I++ is an increment. Instead, you want to talk about what were you thinking about when you wrote that code. All right, Jared, your question about the code.
I kind of have two questions.
Please. That's twice as good as one.
So instead of writing functions like the open and close file, is it still okay to like, instead of doing that, make labels within main to represent those?
Okay, well, if you make labels within main, the equivalent, if you were in a higher level language, the equivalent to doing that would be to be writing your entire program in main with no functions. And you wouldn't do that, right?
No.
Okay, there's your answer.
Okay, and could we also go through the clear fixed function and like why that function exists?
Okay, clear fixed, anytime you want to duplicate code, that's a situation that's screaming out to make it a function. If you ever copy code and paste it someplace else, it should be a function.
Okay.
The reason is if you duplicate code by pasting it or simply by duplicating it, and you do that in 10 places, you discover a bug in that code and you fix it in 9 out of the 10 places, you still have a bug. So instead of duplicating code, you need to create functions so that the code is found in just one place where you can test it in one place and then you can fix it in one place. So I made a function out of clear fixed because I need to do it both where the buffer is allocated and when each time I start reading a new line. I need to do the same exact mem set. That's why I made it a function.
Okay.
Good, Jared. Thank you. Cephas, your question.
I
Muted.
asked a question.
I know, but I love your question so much. I want to hear another one.
There's so many other people to ask questions there.
We're going to ask them all, every single one of them.
Okay.
Oh, I did start the transcript, right? Yeah, good. All right, go ahead.
Fine. Can I go later after I review more of the code and find a question?
Okay, that's fair
I do
enough.
not
Rebecca?
currently have one.
Mute. I always forget to do that. With the closed file and the free buffers, and commonly, when I try and create a program, I don't think about cleaning up until after I wrote everything. And is that a bad practice or anything that I should change to make this more effective and better idea?
That's a really good question. Thank you. At a minimum, you should stub out the cleanup. At the moment that you allocate a resource, you should at least stub in the cleaning up of the resource. I personally will write the code to clean it up immediately after writing the code to allocate it. Okay. Now here's a couple of reasons why. The biggest reason is exactly the same as why I always say, write a little, test a little. Right? So I say, write a little, test a little, so that you're always testing and that you're moving on from a sure footing. Now, if you defer writing the cleanup code, you may forget about it. So I will not forget to clean it up because I write the cleanup code immediately after I write the code to do the allocation. Does that make sense?
Yeah, it does.
So I did say, however, that you could simply stub the cleanup code. The stub itself could serve as a reminder that you have to finish it. So, for example, in higher level languages, you might have this will definitely get your attention. Okay?
I have a question.
I'm so pleased.
Was it? What is wrong with you, Jordan? Anyway, so in the buffer, the only reason I actually use an incrementer is to do the check of when we have reached the end state versus the beginning state.
Mm-hmm.
I don't see where you are doing that, like where, if the buffer is full versus when the buffer is empty, because you can't generally just compare the tail and head, because
Well,
it would be
I
this.
haven't written that code. That's not part of the code that I've written so far. And because I'm not going to write the whole project. But let me give you the example at the higher level, right? So suppose you have, so you have a structure, and who knows how big it is. And suppose you have foo star, well, suppose you have an array. Okay. So in the higher level language, you could have a counter. So int I, int index, and then a subindex, right? That's reasonable. And if the index is greater than or equal to the count, then, oh shit, I'm writing Python. You can
Ew.
set the index back to 0, right? Otherwise, index plus plus. Okay, so maybe here. Now it's not Python anymore, but who knows? Okay. Now, in order to do a subindex, the compiler is going to generate all sorts of address arithmetic. That address arithmetic takes away the burden of using just an integer as your counter. Because think about it, when you write this, right, what's being output by the compiler is a load of the address of A, then a load of index, multiply index by the size of foo, then add that to the address of A, then dereference that address. Okay? All of that is right here. So what I'm suggesting is that you would do something like this. You could say foo star end of foo is equal to A plus 100. Now, this is in C++, so the compiler knows how big a foo is. And when you say plus 100, that is actually going to be 100 times the size of foo. Then now you don't need a counter anymore. So while if you want to index through this whole array, so you say foo star pointer equals A, right? Start of the array. While pointer is less than end of foo, and then P pointer plus plus. So PTR is now doing the duty of both the pointer to the next element, and it's doing the work of the index counter, the loop counter. I actually showed you this in a lesson early on. Yeah, I did show it to you because I remember we talked to something like about strlen. No. str how about string copy?
Yeah.
Char star destination, char star source, and length. Okay, now you could write it like this. For int I equals 0, I less than length, I plus plus, star d, dst sub I equals source sub I, right? Correct? True?
Mm-hmm.
Okay, or you can write it like this. Uh, There, now I don't have a loop counter.
If you do that though, you would lose the location of the beginning of destination, right?
Yeah, but those were local variables.
Oh yeah.
So this was actually kind of unrelated to my question, but whatever.
What was your question then? I thought I
My
was answering
question, the only reason I used an int counter
it.
was to differentiate between the end state, the free state, and the full state of my circular buffer.
Yeah, that's
Essentially, so I didn't use the counter for any of this. I was wondering how you so in the beginning you can say this is empty when head and tail, or whatever you call them, are equal to each other. In your case, I don't think you can do that, since head and tail would be equal to each other when they start looping back.
Yeah, but in your way, when the index was 0, you don't know whether it's full and it looped around, or it's empty and it never moved. What's
I
the
do.
difference?
What do you mean? Because I have a head, a tail, and then in a count. If head and tail are equal to each other and count is non-zero, then we're full. If head and tail are equal to each other and count is 0, then we're empty.
Okay, what data structure are you trying to use? A circular buffer made out of an array or a set of linked lists?
It's an array, I guess. Yeah, I just used an array.
Okay. Okay, well, the reason why I did it the way that I did it is because you can easily run into a bug in trying to get to the right address for a member of an array using an integer. Because remember, you have to remember to load the base address. You have to load the integer. You have to multiply the integer by the size of the width of the array, and then you have to add it to the base address. That gives you the address of a particular member of the array. Whereas I'm just storing an address. The address is always the address of something in the array. Way easier. Okay. So Rebecca asked her question. Cephas, you've now officially asked yours. Nathan.
Okay, so I guess I have two. The first one is I kind of just want you to re-explain why when you move tbuff p into next p, first of all, next p will hold the next pointer. I kind of understand that because it's tbuff sub 0. I kind of understand that. But
Yeah.
then right after you mem set your temporary buffer. And this is when you're allocating your buffers. So why would I mem set the temporary buffer and only keep next p and np?
Okay. Next P. Well, I have tbuff P and next P
Yes.
and right. So by mem setting, I didn't destroy the buffer. I
Oh yeah, yeah.
overloaded with zeros.
Allocated any of the chars. I know. More of the question is why does tbuff p when moved into next p? Why would next p hold the value of next p?
Well, tbuff P is a pointer to the first member, first address in the buffer. And that's what next P is. So I define the next P as being the address in the buffer that's going to be overwritten next.
Okay.
So you know that it's time to loop around if next P is equal to end P.
Okay. Yep, that makes sense now. Then the second question is, I noticed that when you're writing like your hierarchical organization, you use compare branch not 0. Whereas when I was like figuring out how to write an assembly, I found it more familiar to use compare branch 0 and use a branch for the error. Whereas you have a branch for success and continuing the code for error. I'm just wondering if there's benefit to me doing it in that way, where it branches on success and doesn't branch on failure rather than branch on failure and not branch on success.
I'm not sure that one is better than the other, but do the one that makes most sense to you and stick with it.
Okay.
Yeah, so just by always doing it the same way, it requires less thought and you make fewer mistakes. So I will always skip or I usually skip over the error handling.
Okay. Yeah, I think that's all I really had to ask.
Okay, so Jordan.
Yeah, I have a good question. Well, I think it's a good
How do you
question.
know?
So my question is basically, at what point is too many functions? Now, I understand, like, don't write a function that's like add 1 to this or whatever, but like in your code, when you're allocating the buffers, would it be bad practice to write a function that's just allocate tail buffer, allocate intermediate buffer?
Yeah, that'll be fine.
Okay.
Yeah. Yeah. So when you've got code that looks like this, okay, this code, depending upon these names, is very easy to understand. So func A, func B, func C, that doesn't mean anything. So feed the cat walk the dog. If dog crapped on carpet, you know. This is very easy to understand. So I like having my main look like this. Right? Okay, and trademark, yeah. Okay, good. Meadow, please, your question.
So could you just explain like what the like fixed and tail buffer like holding, like how much of it is holding? Does that make sense?
Okay, your volume is very, very low. I think you said, can I explain something about the fixed buffer and the tail buffer?
Yeah, so like what they're like each going to like hold separately.
Okay, well, as discussed in the specification, so the fixed buffer is a large array of char that holds all the chars being read in until a full line is found. Okay, when the full line is found, another buffer of exactly the right size is allocated, and the tail buffer is made to point to it, and the fixed buffer is copied to the new right-sized buffer, and therefore can be used to assemble the next line. Okay? So you have to make some kind of assumption about the longest line that you can support. There are ways around it. You could do it in a more complicated way. But what I did is I assumed that the longest line I'll ever care about is 4,096 characters long. Really, 4,095 characters long, because the last character has to be a 0. Right? So when I find the end of a line, I allocate another buffer, which is sized just right, copy the fixed buffer to the new buffer, make the circular buffer point to the new string. Okay, so let's see, do I still have, is this still working? Hello, QuickTime Player. There's some things about the Mac that just truly fry my shorts. So where is it? Anybody know? Oh, so it's not enough that I switch to QuickTime Player to bring the window back. No, you have to switch to it and go find it someplace else. Stupid Steve Jobs. Okay,
Steve is
so
dead.
It's Mr. Cook now.
yeah, well, Steve Jobs is still ruining my life.
I imagine significant other influences have led to the state of macOS at present.
Okay, so here's fixed. And so this is really big. It's 4096, and it's always reinitialized to zeros. So everywhere along here is, in essence, a null terminator. So if you fill in A, B, C, what's after the C? Well, it's a zero. It's a null terminated. So, so you loop, read one char into the next location in fixed. Is it a new line? So if yes, create a new buff, copy fixed to new buff, have the circular buffer point to new buff. Then zero out fixed and start again. Okay, so your question was, what is the fixed buffer going to hold and what is the tail buffer going to hold? Correct?
Yeah.
Okay, so the fixed buffer is going to be the incoming characters as you read them in, and you're looking to assemble a full line of text. And then when you have assembled a full line of text, the circular buffer, here's a line, line 1, here's line 2, here's line 3, etc. Okay, we've got 2 minutes left. Jacob.
So I guess I'm still having a little bit of confusion. In the demonstration file, a couple different times we redefine the labels 1 and 99. However, how does the computer know if we're branching prior to redefining this label that we've since changed the definition?
Right, that's the F and the R. Let me show you that real quick. Just go away. Okay, so here's a 1 and a 2. And if I look up above, here's a 1 and a 2. But if you notice, every time I refer to one of these temporary labels, I tell it which direction to look. So there's an F that says, go find the temporary label number 1. That's below me. And here it says, go find temporary label 2. That's below me, forward. On the other hand, you'll see a, not in this function, but especially when you have a loop. Let's see, branch to 2. Okay, this is to go, not a R, it's B. Branch to temporary label 1, but look above me. Okay, so backwards versus forwards. Okay, and that way you can reuse the temporary labels as many times as you want.
Okay, thank you.
All right. Caleb, question. Class is over right now. How fast is your question?
How are you doing?
I'm doing great. Morgan.
For the R equals, those for the dot R equals, you're supposed to only use registers 19 through 20, because if you BL, like if it's something else, it'd still go away.
No, you could use any register you want. These are the registers that I'm setting aside as if they were global variables,
Okay.
right? So think of the other registers, the ones below 20,
Mhm.
and think of those as local variables.
Okay.
Okay. Now, what I just said is not strictly right, but it works well enough. So you can use these REQs for any register, but remember that registers 0 through 18 or so are almost guaranteed to be destroyed if you call another function. So it's the 19 through 30 which are required to be preserved when you come back from a function. All right. Look, next week, the next class is review, then you have a midterm. So you have to come with your questions. Now, what's going to be on the midterm? Well, anything that we've talked about this term. So I suggest, for a reminder, you go back to the progress file. Stupid Mac. So if you go to the progress file, GitHub here, take a look at the progress. Okay, these are all the things we've talked about. So this is what's on the test. Okay. Stevens, are you playing a keyboard or using a keyboard? You're playing music, aren't you?
Yeah.
Yeah. Is it because my lessons are so lyrical?
No, it's just because that's what I do.
Okay. Okay, class is over. We'll see you on Thursday.
Thank you so much for this.
Are you being snarky or serious?
No, this was a very, very good
Thank you.
class.
Thank you very much.
Yeah, I really, really appreciate it.
Okay, good. My pleasure. Bye-bye.